So let's continue with the discussion. We were at the bottom tier, that is tier 3. We have completed the discussion about the bottom tier. Okay. Now we will move into the next tier, that is tier 2 or middle tier. I have already discussed about the first tier, the top tier, that is front end tools, and I have completed a discussion about the bottom tier. Now we are moving into the second tier, that is OLAP server or tier 2. This tier is a very important, very important. Its role is very important. Its job is very important, and that OLAP operation that we have done in the previous class, like drill down, drill up, is actually taking place in this tier, in tier 2 or bottom tier. So every sort of OLAP tools and their operations are generally working in this bottom tier. Okay, which is called OLAP server tier. So this OLAP server tier is typically implemented either by using ROLAP or MOLAP. Remember, ROLAP or MOLAP. ROLAP means relational OLAP server, or MOLAP means multi-dimensional OLAP server. Relational OLAP, ROLAP, or MOLAP. So either any one of the OLAP server will be used to implement this middle tier OLAP server. Okay. So what is ROLAP? ROLAP is nothing but an extended relational database management system. It is nothing but an extended relational database management system which generally requires to map the operations on multidimensional data into the standard operation of relational data. Okay, it actually maps the operations of multidimensional data into the standard operation of the relational data. That means ROLAP generally do the operation after mapping it from multidimensional data operation to relational database operations. Not direct connection or direct operations, it cannot perform ROLAP. And MOLAP is called multidimensional OLAP, which is most popular and most widely used. It's a special purpose server which directly implements multidimensional data in its operations. Directly implements. It does not need any sort of mapping conversion from multidimensional operation to standard relational database operations. It does not need that sort of mapping. It directly implements those operations and those multidimensional data directly on the multidimensional data warehouses. Okay, so that's why MOLAP is more popular. But one disadvantage of MOLAP is that MOLAP is a little bit expensive. It's costly to implement compared to ROLAP. And there is one more OLAP sometimes we will see is nowadays is popular, which is called HOLAP, hybrid OLAP, which is nothing but a combination of the ROLAP and MOLAP. Look, ROLAP has an advantage of fast computation or pre-computation. Very fast computing power has the ROLAP. But MOLAP has a advantage of direct no mapping process, direct operations. It implements direct multidimensional data and operations. So HOLAP, hybrid OLAP, is generally taking the advantages from both ROLAP and MOLAP and build that efficient and ideal server for middle tier, that is OLAP server tier. Okay. So this is all about the three different tier and their architectures of our data warehouse system. Is it understood by everyone? Is it clear to everyone? সবাই বুঝতে পারলে? Is it clear to everyone?
Yes, sir.
Let's look at one small video.
Yes, sir.
Let's look at one small video regarding it. Look at very carefully. One second. Need to give you the share sound. Listen very carefully, okay?
The data revolution is transforming society through the use of emerging technologies, such as machine learning and artificial intelligence. These technologies are also helping our doctors make better decisions, but require clean, organized, usable data. In a hospital, many different information buckets exist. There's a bucket for patient registration, pharmacy data, lab results, and so on. These buckets exist as separate source systems and are constantly being added to. To enable advanced analytics, these data need to be cleaned and organized. Mapping a patient's hospital journey from one source system to another can be very difficult, and pulling meaningful data together for a report can take months. An enterprise data warehouse was built at St. Michael's Hospital to bring this rich but disparate hospital data together in one place, in a more meaningful and integrated way. The database is comprised of 3 layers: raw staging layer, atomic layer, and a dimensional layer. The first layer is the raw staging area. Copies of data from the information buckets are dumped into this common area every 24 hours in their original form. The data is still disconnected and not in a structure that is conducive to analysis. You can think of it as a data holding tank. The connections between the different pieces of data are made in the second layer, called the atomic layer. It's here that data are extracted and broken down into discrete bits of information and then transformed into a highly normalized data structure. The data are reorganized so that they're linked together, optimized for storage, and absent of duplicate data. In other words, all of the data about a patient's journey are getting pulled out and woven together to tell a coherent story, like a data spider web. While the atomic layer contains lots of cleaned, linked data, not all of it is relevant for analysis, and long chains of linked data can be difficult to analyze. This takes us to the third dimensional layer of the database, which contains the data from the atomic layer that is accessed most frequently. Data in the dimensional layer are repackaged to allow for more efficient data queries into a star schema data structure because of its resemblance to a star-like structure. In the middle of the star is the fact table. A fact table holds information about things you can measure or count, and every row of a fact table is a different instance of that event. For example, the emergency encounter fact table is a record of all emergency visits that have occurred in the hospital, and each row of that table represents a single emergency visit. Consequently, a patient who has many emergency visits will have many rows of data in this table. Branching out from the fact table are dimension tables. These are the arms of the star structure. Dimension tables hold the contextual data associated with fact table events. They describe the who, what, where, when, and how of each of those events, and link to fact table rows via a matching ID key. For example, the emergency encounter fact table links to a practitioner dimension table, and it's here that you would find all the details about the physician associated with an emergency visit. It also links to a patient dimension, who is the patient, and an arrival mode dimension, how did the patient get to the hospital. This warehouse of fact tables and dimension tables, data spider webs, and data buckets is enabling cutting-edge analytics at St. Michael's Hospital to improve outcomes for the patients we care for.
Okay, do you understand what it has been discussed? I already discussed all these things: fact tables, dimension tables, enterprise data warehouse. Look, based on the architecture which I already discussed, based on this architecture, we can divide the entire data warehouse into 3 types. These are the 3 types: enterprise data warehouse, data mart, and virtual data warehouse. I have already discussed these 2 things multiple times: enterprise and data mart, which has been already discussed in the video as well. So enterprise data warehouse is generally represents the entire organizations. It will generally focuses on the common subjects which spanning throughout the entire organizations, like all the like the example which has been given in the video, like hospital management. So in case of hospital management, it will discuss about the pharmacy department, lab, pathology lab department, hospital beds, then the doctors department. So all the things it will discuss about it. Okay. Whereas in case of data mart, so enterprise is generally consist with a summarized of the data with the gigabytes, terabytes, and beyond the terabytes of data. So size of the data warehouse, enterprise data warehouse is much bigger than any other data warehouse. Okay, so enterprise data warehouse it can be maybe implemented on traditional mainframes or computer super servers. Means normal computer is not suitable to implement enterprise warehouse. For special kind of computer, we require to implement that enterprise warehouse, like your super servers or mainframe or parallel sort of architecture, which will give you that support to implement such a huge amount of subjects in terms of data warehouse, interpret data warehouse. Whereas in data market, it is a corporate wide or corporate specific, department specific data. A department specific data. It means the selective subjects it will choose. Like it will only discuss about the pathology lab, not the entire, only the pathology lab department and its employees and its patients and everything. Only pathology lab department. So it focus only on selected subjects, not the entire organization. So that's why the data mart require low cost departmental servers, Unix, Linux based or Unix or Windows based servers, okay, to handle the data mart. Instead of enterprise data warehouse. And one more thing, to implement an enterprise data warehouse, we require almost 1 year of time. Almost 1 year. It may be more than 1 year. Whereas to implement a data mart, we require 1 or 2 days of time, and not more than a week. Okay, even less than a week time to implement a data mart. Okay, so based on your requirement, whether you are going to implement a data enterprise warehouse or whether you are going to implement a data mart, that is totally the choice of the organization or the people who are working behind of it. Okay, and various peoples are working behind of these data warehouses. I already discussed, like business skill members, data analytics members, some professionals members, some executives, business executives are also working behind this data warehouse and its implementation. And third type of data warehouse is virtual data warehouse. These three classification is based on the architecture of the data warehouse. Okay, virtual data warehouse, which is nothing but a set of views over operational databases, and only some of the possible summary views may be materialized. Okay, so it generally represents a set of views over the operational databases. And efficient query processing are actually using in case of virtual warehouses for make a summary views. Okay, and it is a virtual warehouse is very easy to build, but require excess capacity on operational database servers. Okay, but most widely warehouse is data mart among all the warehouses. Okay, most widely used warehouses. Okay, so this is all about today's class. I think it is clear to everyone. So I am sharing the link of the Weka and the Python in your Google Classroom. Everyone check it out. And I'm going to discuss. I'm going to right now. I'm going to calling your roll numbers. Everyone, please be attentive. Okay.
Okay, sir.
Okay. Today 5-3. Amangiri, please be present. Amangiri, absent.
Present, sir. Present.
Okay. Anil Das.
Present, sir. Present, sir.
Yes. Onudip Das.
Yes, sir. Yes, sir. Yes, sir.
Arindam Panda.
Present, sir.
Orko Naran Jess. I'm sharing the screen. Okay. Orko Naran Jess. Absent. Shivam Sharma.
Present, sir.
Devashree
Present,
Roy
sir.
Chaudhary.
Present, sir. Present, sir.
Okay. Deepak Kumar or Deepak Singh.
Present, sir.
Okay.
Present, sir. Present.
Pramod Kumar Pandey.
Present, sir.
Sagar Mishra.
Yes, sir.
Shagni Ghosh. Absent. Sanjit Shom.
Present, sir. Present, sir. Present.
Saurav Kumar.
Present, sir.
Snehashish Dam.
Present, sir.
Shoham Karmakar.
Present, sir.
Shomallo Chaudhary. Shomallo Chaudhary. Shomallo, are you there? Shomallo absent.
Present, sir.
Who is this? Shomallo.
Sir, present. Huh.
Okay. Shomik Sen. Roll number 27.
Absent.
Roll number 28. Shobik De.
Present, sir.
Sunil Kumar. Roll number 29.
Yes, sir.
Sunil Kumar. Okay. Swarnadeep
Yes, sir.
Ghosh. Shonadip Ghosh,
Present, sir. Present, sir.
Umrao Singh,
Sir, present.
Umrao Singh, present.
Hello, present, sir.
Okay. Ankita Mishra,
Yes, sir.
Annesha Bose,
Present, sir.
Koel Mondol,
Yes, sir.
Mudhurima Mukherjee,
Present, sir.
Piali Paul,
Yes, sir.
Shayani Pal, absent. Tania Saxena,
Yes, sir. Yes, sir.
who is
Sir,
this?
Shiny Pal, sir.
কোথায় ছিলে? Tania Saxena,
Sir, mic to.
Tania Saxena,
Absent, sir.
Shashank Yadav,
Present, sir.
Tuhin Sarkar,
Present, sir.
present. Okay.
Yes, sir.
Kaustavi Das,
Present, sir.
Shahini Mollik.
Present, sir.
Okay. Okay. Thank you for attending on my classes. Okay. See you in the next week. So আমি তোমাদের হয়তো একটা অ্যাসাইনমেন্ট দেবো. All of you please do it. Okay. Do the assignment, submit the assignment. I have sent the assignment in Google Classroom.
স্যার একটু টাইম দেবেন স্যার অ্যাসাইনমেন্টে
হ্যাঁ
অনেকগুলো অ্যাসাইনমেন্ট আছে
ওকে নো প্রবলেম টাইম দেবো কোনো অসুবিধা নেই তো
স্যার আফটার সানডে দিন না
ঠিক আছে আমার এক দুদিন টাইম লাগবে অ্যাসাইনমেন্টটা দিতে ডোন্ট ওয়ারি ঠিক আছে
ওকে স্যার
তোমরা একটু রিভাইজ দেওয়া স্টার্ট করো তোমাদের কিন্তু ফার্স্ট মিড টার্ম হয়তো কাছে চলে আসছে রিভাইজ দেওয়া স্টার্ট করো ওকে
ওকে
স্যার অ্যাক্সেস পাচ্ছি না স্যার আমাদের ওই আপনারা হ্যাশ পোর্টালে যেগুলো দিচ্ছেন না ওগুলোর অ্যাক্সেসই পাইনি
আমি
এখন
তো
আমরা
ইউটিউবে দিয়ে দিচ্ছি বাবা সব তো ইউটিউবে তুলে দিচ্ছি
আপনারটা আছে না আপনারটা আছে সব সাবজেক্ট তো নেই না
আমি ওই জন্যই হ্যাশ পোর্টাল এগুলো কোনো কিছুর উপর ভরসা করি না আমি ইউটিউবে দিয়ে দিচ্ছি কারণ আমার গুগল সার্চটা নিজে গুগল সার্চে ডাউন হয়ে পড়ে আছে সুতরাং আমি এটা ভরসা করছি না আমি এই জন্য তোমাদের যা দিচ্ছি সমস্ত ক্লাসরুম গুগল ক্লাসরুম আর ইউটিউবে তুলে দিচ্ছি কারণ তোমাদের আমার সাবজেক্ট সম্বন্ধে অন্তত কোনো কমপ্লেন থাকার কথা নয় ওকে ঠিক আছে চলো
Yes,
চলো ঠিক আছে
থ্যাংক ইউ স্যার
থ্যাংক ইউ
Thank you, sir. Okay, sir. Thank you.